I want to give a very special thank you to JJ Snow, who introduced us to the Mentor Project, and Jack Scott for helping us dream this collaboration up. We're so excited. And then before we get started officially, I want to welcome a couple of people to say a few words, some very special folks who have helped make this happen. So first up is the Mentor Project's Chief Marketing Officer, Tina Parker. Hi, Tina.
Hi, how are you guys?
Yeah, thank you so much for joining us today. So why don't you tell everyone a little bit about the Mentor Project and how partnerships like ours will bring opportunities to youth across the world.
Absolutely. Thank you, Jenna. Thank you, everybody, for being on today. This is so exciting. And on behalf of our CEO, Debbie Hauser, I want to thank the Embedded Ventures team. You guys have been amazing. Robeson County Public Schools, you guys pulled it out, and I so appreciate all of the work that you all have done to make this a possibility for your students. And for Ad Astra, who's going to help us continue this legacy in the community, it's turning this idea into reality has been awesome. So the Mentor Project, just so you guys know, we are on a mission to connect the best and brightest expert mentors for free to students around the world. And you guys are making that possible with us. It's these partnerships, like the ones you see today, that give kids opportunities that they may not have had otherwise and to achieve in really big ways. And so we're very, very excited to roll this out with you all, and let's get started.
Yay! And we have Robeson County Schools' very own Dr. Herman Locklear. He's the Career and Technical Education Director, and we're so thankful to have the opportunity to work with him and his team to coordinate this project for all the students at Robeson County. So Dr. Herman, why don't you help kick us off by saying a few words as well?
Okay, here we go.
Yay!
Okay, well, it's going in and out.
There you are.
Okay. Yes, I would like to just say thanks for everybody that has been a part of this, Embedded Ventures, the Mentor Project. We struggle sometimes with funding not to have these opportunities. And I think it's a great opportunity, especially for middle school grades, to be able to see what is really out there in the real world. And by partnering up with you folks, we made a great effort and we're getting it started. I hope this is just going to be a pilot program that we could continue maybe in the fall and even do greater things. Again, I appreciate everything that Embedded Adventures and the Mentor Project is doing. Shout out to you folks. Keep up the good work, because without you, this would not have been possible. Thank you.
Oh, y'all, we're so excited. And I can see the students back there. Hey, everybody. Are y'all excited?
Now excited?
Hello.
They are.
Over in North Carolina. I love it. My mom was born and raised in Fayetteville, North Carolina. So North Carolina is very near and dear to my heart. And I'm born and raised in Birmingham, Alabama, so not too far. Well, yay, y'all. Thank you so much. And, thank you, Robeson County Schools, who totally made this happen. Miss Robin Johnson from Littlefield Middle School, Miss Phyllis King from Lumberton Junior High School, Mr. Jesse Bullard from Pembroke Middle School. Thank y'all so much for making this happen. We cannot wait to get started. And Jess Frazelle, are you on the line now?
Yeah, I'm here.
Jess, what's going on? Okay, good. Before we started, I was like, oh, we gotta make sure Jess is here. So quickly, one more thing before we jump into the project. Just to let y'all know, Embedded Ventures, we're the skunk works of deep tech venture capital. We privately invest in pre-seed and seed stage startups solving complex problems. The Mentor Project, just to elaborate a little bit more, they're a registered 501c3 nonprofit. Their mentors are experts in science, technology, engineering, the arts, mathematics, business, law, and from developing a patent on how to use credit cards on the internet to insights on space exploration and astronomy to titans of industry and world-class technologists. They really mentor and share their skills and knowledge to inspire and guide their mentees. So we are excited to jump in and join their team and bring STEM to anyone and everyone in the world here. And we like doing this live on Twitch because we want viewers to see the learning process live. Learning is really messy. You make mistakes, that's okay. This also lets you, the viewers, realize, maybe your interests in STEM while interacting with me, and while I learn alongside all of you. And also, other people around the world can find our stream. We're super passionate about STEM and want to give as many people the opportunity to learn and develop in this field. And when I was growing up, I never saw anyone like myself in tech or doing anything like this. As a kid, I had a cardboard cutout of Beyonce in my bedroom and was like, I'm going to be a backup dancer for Beyonce, and that's me done. And I was also very interested in computers and all of that at the same time. I just never really imagined that it was a space for me until I then joined tech right out of college, and then now here I am in venture capital. So, all right, y'all, we are going to build an 8-bit computer from scratch. We were actually inspired to do this from a video series that Ben Eater did on YouTube of himself building one, and we thought we could show you what it's like to learn the project as me, the non-technologist of the team. So we're going to have joining us Jordan Noone. He's an engineer by trade. He is the youngest person in the world to fly a rocket to space. And he's the founder of the second most valuable private space company in the world, which is Relativity Space. So he built Relativity to over 250 people, raised over $700 million in venture capital. He then stepped down from his full-time role there to build something new, and I intercepted and was like, all right, let's go. Why don't you join Embedded and launch a VC firm with me? And after like a week, he said yeah. Also, I'm going to have Jessie Frazelle here. Maybe we can pop their social media links in the chat here. Jess is famous, even though she won't admit it. She has like the most quality Twitter following I've seen. Just like incredible technologists follow her and want to know what she's working on. She's incredibly smart and super fun, and we're thankful to have her be a part of all of this and just be a team player and help us with pretty much any and every project we work on. She's the co-founder and chief product officer of Oxide Computer Company, building next generation hyperscaler infrastructure. And so, hey guys, what's going on? Jordan and Jess.
Hello, this is Jordan. I'm excited to be on today.
I'm excited to be here to do this. Oh.
Jess, Eric.dev says Jess is famous. She's a programming superhero. That's true. We know this.
No.
She totally is. Well, awesome. Why don't we get going? And y'all, just so you know, we'll pop it back in the chat. But add us, add our Discord channel, because we'll be, putting little tidbits in there. Y'all, I'm going to change the music because this is very sad music. Let's see. There. Oh, yeah, that's better. Okay. And also make sure that, we'll share kind of the instructions, the supplies, a little bit more about in the chat here, and so y'all can make sure that you have everything that you need. Otherwise, why don't we get going? And y'all, I'm doing this from scratch, so I'm starting here fresh with all of you. So Jordan and Jess, let's do it.
All right, well, we will jump in. Jenna, if you want to switch to the close-up view of the breadboard, perfect. We'll start running through things. But Jenna, you have some instructions in front of you that we'll step through together, and they're available on the link that Britt sent out in the Twitch chat. But we can hop in. So step one here, we're going to build one of 3 different clocks that'll be on this breadboard. Those 3 clocks will actually be able to switch between to control the computer that we're building in different ways at different speeds, either automatically or manually. The manual mode will be very helpful for debugging. And when we have an issue down the road, when we're working on the rest of the computer, that we'll be able to kind of manually cycle the computer in a way that lets us try and see what the computer is doing. So the first step, Jenna has the breadboard in front of her.
And I'm just pulling everything out. I'm pulling all of everything that I think I need today, and I'm just gonna put it down here. Y'all start seeing it come up here next to the breadboard. What am I gonna need next, Jordan?
We're going to start with the breadboard, and how about you just get everything nearby. So unpack what is kit 1 from Ben Eater's set. Okay. There, you should have a lot in front of you. And the first thing you're actually going to need, and we're going to look at step 1.2.1, you're going to need one of the 555 timers.
Ah.
In that plastic sheet, there's 6 different integrated circuits. There's 3 different kinds of logic gates, which we'll use to make decisions between the different clocks. And you'll have 3 different timers there as well.
Awesome. Okay. Let's see here. So I believe that our Jordan and Jess, how do we know which one is the 555 timer?
The 3 bigger circuits are the logic gates, and each of the kits will actually come with a pamphlet that helps identify them. We'll just point them out here, but the way that I know which ones are which, it actually have labels on them, which you can look up in the Kit 1 pamphlet. So the 3 longer ones are the logic gates, and the 3 smaller ones are all the same 555 timers. So just go ahead and grab one. There it is, little
got it.
Of the 555 timers, and those are also a throwback to when Jenna did her 555 timer control blinky light.
Yeah.
Then, which was her first ever stream, actually.
Sure
So
was.
let's throw this onto the board. We're at step 1.2.1, and in the instructions you'll see as well that the 555 timers have the label LM555CN, which is another way to tell which one's which.
All right. And, sorry, where are we in the instructions?
1.2.1.
Got it.
It's on page, I think it's page 3.
Okay. And y'all, so with this, I actually use tweezers a lot. So if you don't have a set of tweezers, I recommend finding a pair. But maybe it's just because these crazy nails. So you are going to have to know where 1 is. And so it's actually on the 555 timer. It's kind of hard. Let's see. Hold up. I don't know actually that these have that same.
If you look at them, they'll have the notch. The notch is generally the way. It may slightly look different. There you see that big notch on what's the right-hand side of the screen.
Yep.
Right side of your palm. That's the top. So that's
Okay.
where pin 1 and pin 8 will be per the diagram.
Great. How do you know which side is 1 and which side is 8?
When you have the notch on the top, so like if you reference that as top, the left side will have pin 1. It'll go from top to bottom. It'll go 1, 2, 3, 4, and then on the right hand side, it's bottom to top. So 5, 6, and then 5, 6, 7, 8.
So just so you know, the diagram that we have in here is incorrect. If you have this same 555 timer, you're going to have the notch on the top middle. And so then you're going to go, the first notch on the left is 1.
Yeah, and regardless, the notch is on the top. You know, regardless of it being like the half notch or like the full notch.
Yeah, sweet. Alrighty. Where are we going with this?
We're going to go pretty close to the left edge of the breadboard. So it's kind of far left as you can get, but maybe leave like 1 or 2 spaces on there.
Okay.
Along the middle, kind of have it straddle the middle of the board.
Okay, so far left, so maybe all the way over here?
Yeah, and try to have the notch on the left-hand side.
How's that?
Maybe go 1 or 2 from the end. So you see how like the plus-minus rows, they have, they start a little later. Try to align them with that. Yeah, that's perfect. So maybe two blank holes.
Let me make sure that this is, sorry, I'm gonna have to hold it up here. There we go. How's that?
Perfect, and it's all the way in.
Alrighty. Sure is.
Okay, so that is good. We'll next go to start plugging in from each of the 8 pins to a variety of other locations on there. So Jenna, go ahead and show the jumper kit you have, that box full of jumpers.
Yes.
So everyone knows what we're referring to. Hold on.
Jordan, sorry, your audio cut out. Oh, Jess, how about those videos of making the jumpers perfectly aligned and color coordinated?
These wires are amazing because they're like so perfectly cut, but then it gives me unrealistic goals for myself in like the later portions of the kit where we have to make our own wires.
I know. We're gonna have to practice. We'll have to get, because the later in the kit they're on rolls. And so you'll use like a wire stripper and everything. And then like, I actually watched the video. Jess, did you watch it on how he like aligns it perfectly?
It's so good.
We should do it. The wires are so pretty. I know they are. Eric.Deb, you have the same wires, and I get so sad when I need one that's slightly too big. Oh goodness, y'all. It's gonna be funny. But here we go. Jordan, I don't know if Jordan's audio popped up, but Jess, why don't you tell everyone here and all of our students in North Carolina how you got into STEM?
Yeah, so I loved computers kind of all my life. And then I was a math major in college, and I didn't really want to become a math professor doing proofs all day. So I really like computer science and all the classes I took for that. So then I decided to do that for my job, I guess.
I love it. I love it.
Awesome. I'm back on.
Perfect.
Sorry, I tricked myself into thinking my audio was working. But no, so with the jumpers, the first step, and this will be, or the first pin we're going to connect to is pin 8, which is the power pin. And so pin 8 right now is on the top left-hand side of the chip. And we're going to connect pin 8 to the power row, so that plus row on the top side.
So this is pin 8 here, and then that's going to be power, correct?
Yeah.
And so these jumpers, do I need to try to find one that seems like it'll fit?
When I was playing with them, I generally did kind of the shortest jumper that worked.
So like one of these, maybe?
That's a little long.
Okay.
Maybe one of those like little yellow ones. The yellow, kind of that little pile with kind of like 2 or 3 pin distances apart.
Maybe these, actually.
They're definitely small. The tweezers will help a lot.
Yeah. All right, y'all. Can y'all see this? So this is going to be pin 8.
You're slightly off.
How's that?
That's perfect.
Pin 8, and so ground is the negative here, and then power is going to be positive over here. Oh no, y'all, this one's a little too short.
You can move it over a little closer, because you can go from any of the pins in that row.
So I can go here to here and just make it fit nicely.
That's
perfect. Here we go. Again, y'all, I think it's the nails that make me really need to use the tweezers, but here we go. That looks pretty neat, y'all. That looks nice and tidy. How do we do there?
That's perfect. That's perfect. So now we're going to do a lot more of those.
Okay.
So we're going to start going through these. So that was step 1.2.3, and now we're going to go 1.2.4. So you're going to connect pin 1, so the pin on the top left. Okay. You're going to connect a ground.
And maybe Jess and Jordan, can y'all explain to everyone, what do jumpers do on this breadboard?
Yeah, so the jumpers are how we're connecting various things. Like when we plug in power actually eventually to the 2 sides with power and ground, then like that will stream all throughout kind of the parallel, like vertical lines there, which is cool. So then how we get it onto like the components is by using the jumpers to like feed it there. If that makes sense.
Yeah. How's that?
Oh, that's really good. That is really good. Oh, you actually, I think, want to go to ground. You have them going to positive.
Oh, wait. Oh, gosh. You're right. I did. There we go. Whoops. See, y'all, we make mistakes. Especially me.
No, we all mess these up. The first time I put any of this stuff together, even recently, I set some of the stuff on fire. So.
Y'all, he did.
I'm the only one that would ever do that.
He was practicing, and we were like, ooh, it smells like something's burning. Oh, gosh. Okay, what's next?
Okay, so we're gonna go, and we're gonna need to find a resistor. You're gonna need to find a 1,000 ohm resistor.
Okay, all right, y'all. So we're gonna need to find our color chart, which I believe is at the very bottom of this. Is that correct, y'all? The instructions list, yes. So if you go to the very last page of the instructions list, you're gonna see a resistor color code chart. Jess and Jordan, can y'all explain to everyone, how do you read a color code chart like this?
Jess, you want to take this one?
Yeah, so basically you're going to do some math between the various colors, and then multiply like each color, you know, the actual code that's on the chart together to get like the actual value of the resistor. Great. So which one are we looking at? Sorry.
I'm gonna get out my handy dandy. We're gonna need a 1000 ohm resistor to connect pin 8 to pin 7. And
so that would be.
Okay, I have a few of these.
Black, red. Is that right?
And y'all, I have to admit, my vision is not the best at seeing these colors properly. So I might need Jess and Jordan, y'all, to identify it for me. Although I do have some handy dandy glasses somewhere that I'll have to get out here in a little bit. Okay, so let's see, what should the color pattern be?
Yeah, so that one should be brown, black, red. Of course, I had to double check just so that everyone doesn't think that I'm insane. You always gotta double check.
I have a feeling, let's see, I have a feeling this one's correct, but come on thing. Here, let me hold this up. Is that right?
Yeah.
Brown, black, red? Awesome. And y'all, I'm not checking, I need to check the Zoom chat. In North Carolina, if y'all have any questions coming in, throw them in the chat, and then Jess or Jordan, if y'all can kind of monitor the chat and see what's going on, in case they have any questions while they're doing this as well. Okay, so awesome.
But I think did you find the 1000 ohm, or which one went by? My audio.
We found it, but inevitability in game. You can always use multimeter to measure the resistor. I'm always bad at reading those tiny colors. Oh my gosh, amazing.
We'll have to add that to your toolkit, Jenna.
Let's add that to my toolkit. That's awesome. Thank you. Inevitability in game. Okay, so we're gonna connect the 1000 ohm resistor to connect pin 8 to pin 7. Okay, so that's gonna be
top right.
So we got 1, 2, 3, 4, 5, 6, 7. This is 7 and 8 here. So we're gonna go bam, and then we're gonna go. Uh-oh, y'all, I'm gonna need my tweezers again. And then we're gonna go bam. How's that?
That looks awesome.
Okay. I want to make sure that it's nice and pretty. How's that?
That looks really good.
Great. And just so everyone knows, these streams are going to be 45 minutes every Tuesday and Thursday at 10 a.m. And so we only have about 15 more minutes here. So we'll try to plow through a little bit more. We will, we'll be back on Thursday, and we'll kind of jump right into the project for future streams and make sure that we make a lot of progress each day. We're building an 8-bit computer on breadboards. How cool is that?
Awesome. So let's jump in. We're going to keep scrolling through these. So step 1.2.6, we're going to connect pin 4 to power, so the positive row.
Okay. Connect pin 4 to power. Let's see. Sorry, y'all. I gotta get my tweezers. Jordan, how did you get into STEM?
How did I get into STEM? That's a good question. That's a really good question. I think a lot of it was an accident. I didn't really know what I wanted to do. I still don't really know what I want to do.
I don't believe that.
And it made sense at the time. But I always liked tinkering with things. I like playing with Legos and building things as a kid, and it was just a natural extension of that. But I never really grew up wanting to be an engineer. I was going through my 5th grade yearbook recently, and I saw that I wanted to be, or at least I had written in it that I wanted to be an accountant when I grew up. Which surprised me. I don't know why I did that.
Well, now you're in VC, so.
Very similar.
Y'all, when I was a kid, I literally begged my mom for Halloween because all I wanted to be when I grew up was a teenager. And so I had begged my mom, please let me dress up like a teenager. for Halloween. That's what I want to be when I grow up. I wanted to carry a long purse because I was the youngest of all my siblings. My sister always carried this long purse, and I thought that was so cool. And my babysitter carried a long purse too. So that Halloween, I tripped and busted my chin open. Sorry, TMI, and had to get stitches. And my mom felt bad for me and let me pass out candy dressed like a teenager. It was amazing. So I got to be a teenager.
That's awesome. That's awesome.
Alrighty, so we've done that. We've connected pin 4 to power.
And now you're going to connect pin 6 to pin 2. So this one's actually kind of cross country there because it's from opposite sides. You'll want a longer jumper,
1,
and then you'll
2,
want to go
3, 4. Pin 6 to 2. Okay, so it's going to have to go up and over.
Either up and over or around. What I've seen done is kind of like to do like bend it into a U shape, but a flat U, and then go around the bottom of the chip. But choose your own adventure.
These are actually all kind of pre-shaped. These jumpers.
They're very bendable.
So let me see here. I'm actually gonna go like this. So we're going from pin 6 to pin 2. All right, y'all. Yeah. Any questions coming through in that chat? Yeah, every Tuesday and Thursday. Yeah, if anyone just joined, we're building an 8-bit computer from scratch on breadboards. Jordan, maybe you can tell everyone a little bit more about Embedded Ventures.
Yeah, Embedded is the skunkworks of venture capital, early stage venture capital. So what we do is we invest in companies that are developing technologies that are, that we see as valuable, that we see as growing, and we back founders that we really believe in. But if you check out our website, there's a pretty extensive list of the technology sectors that we invest in. It's what we call deep tech. Deep tech has a lot of definitions, but from our perspective, it's technologies that are defensible. And through technology development, not just having a marketplace or like a consumer perspective on it, but something that's really hardcore tech dev. Even stretching into making circuits by hand, like what Jenna's doing.
Yeah. And Britt, Hannah, thank y'all so much for popping everything in the chat. All right, I think I've done step 1.2.6.
That is really good.
And 1.2.7, sorry. Connect pin 6 to pin 2. And
awesome.
I don't know if we have... Oh, no, sorry, keep going.
I was just going to say we can hop into step 1.2.8.
All righty.
So now we're going to use a capacitor. We haven't placed a capacitor on the board yet. You're actually going to... you have a couple kinds of capacitors in front of you. I recommend actually, and for anyone watching and following along, Jenna, I think you have the Kit 1 book is to the right, the right side of the table right now.
Yes.
If you could open that up, because you need a 0.01 microfarad capacitor, and if you could show the group the parts list on there.
Great. Where's the parts list going to be in here?
Sorry, it's the Ben Eater pamphlet. It's on the right side of your desk.
Sorry, I was in my binder, y'all. So I have a binder that has all of my projects in here. Okay, so we have this.
Awesome. Let me actually run in there really quick and show you. Hold on.
And then let's see. And then I have this. And I assume this is what Jordan's talking about. This is for the breadboard. And then this is
that is it. If you could
this is a great list.
Yeah, if you could show everyone.
Let me go like this.
Awesome. So this shows all the parts, and this is good for everyone to see in case they lose track of what we're talking about. Or if I skim over something. But if you could show the right-hand side, this is where it shows all the different kinds of resistors. It shows even actually those color codes for when we're looking for that one, kilo.
This does kind of cheat a little bit. And it tells you which ones they are.
Yeah, because the resistors you can find out on your own. The capacitors is where it's much harder. So this is where I wanted to stop and show everyone. So Jen, if you could just keep it there for a second.
Yeah.
But specifically that 0.01 microfarad one. So that's specifically where we want y'all to grab those. So you'll want to find a capacitor labeled 103.
Gotcha. And on the Zoom, Jordan, if y'all can just pin my video, because I believe that the students, when y'all talk, they can't see the chart because it flips to your video. So if y'all can just pin my video so that they can see the chart while y'all talking. Thank you.
We'll take care of that really quick.
Alrighty.
But Jen, if you could grab one of the 0.01, that symbol there means micro, and then
So
the F
this one?
stands for farad. Yeah, so those are little capacitors that are in your kit labeled 103.
Okay. That's 104. Ah. I believe these are them. Sorry, y'all. I've kind of made a mess over here, but you can't see it because I have it covered up. Boom. Alrighty. I believe. How many do I need?
You'll just need one.
I believe. So you said it's labeled 103?
Yes.
Alright. I believe that's the one.
Perfect. That looks good on my end.
Awesome. Okay. Where are we going? Let me pull back up my instructions.
So you're going to use that to connect pin 5 to ground.
So we've got 1, 2, 3, 4, 5. And okay, so if you can kind of explain, how do you choose which pin it should go into?
Oh, which pin? It depends on the circuit design. So we're not going to go too much in depth to the details of circuit design on this one. But specifically, there's different ways to configure, and we'll actually see that today and through the rest of the stream, where we're going to build 3 different circuits on top of the 555 timers.
Okay.
And this one specifically, we'll see as we go, but this one's if we want a very consistent clock signal that we can actually tune manually what frequency that signal goes out at.
Great. And so if we're connecting pin 5 to ground, how do you typically choose which pin, where here, like which of these you would choose?
Oh, I think I had misunderstood the question originally. Sorry. That's okay. I generally go to whatever is the shortest path or least in the way. And that's something that's a little bit trial and error. Because you can place something in, a convenient spot now, but then as the rest of the circuit gets built out.
So if we're doing that, we will go here to, oh, hold on, now I gotta bring this close. Here's ground. Ooh, these are a little, I'm gonna need my tweezers. These are a little bendy. Okay. 1, 2, 3, 4, 5. Shortest path would be here. And then ground draws the negative, so that's gonna be right here. How's that?
That looks good to me.
What do you think, Jess?
That looks great.
Yeah. Right on.
And also, one thing Ben explained in the videos is that, like, for the 555 timer, like, for it to work, you actually don't need that little, like, orange capacitor. But to reduce noise and make it, perform better, you add that.
Awesome. Jordan, what was the mistake that was made when we were testing things out for the other project, where we had a small smoke situation?
Oh, there were 2 different situations. One was an LED that all the LEDs we put on here, and we actually have one coming up. You need a resistor in line with them. That resistor takes some of the current, kind of some of the power that's flowing through, and not all of it goes to the LED. And I forgot to place one of those, so the LED no longer is with us. And on the second time, I think I miswired the one of the potentiometers, which is coming up as well.
Right on. Alrighty, what are we doing next?
Perfect. The next thing you're doing is step 1.2.9. So you're going to need now a 1 microfarad capacitor.
Ooh. So we look at our chart.
Yeah, let's look at the chart again. And I think it's further down.
Is it this one?
Let's see. I can only see
part
sorry.
Of we have using we just did that. Pin 5 to ground. Using a 1. That'd be this one. Right?
Yes. 1 microfarad.
There we go. We just did.
Correct.
We just did this one, so now we're here. Awesome. Okay, so let's find that. Let's see. Includes 4 extra. Okay, I have a few that look like this. Let me just get all these out. And what do you think is going to be the best way to identify and differentiate these from each other?
There's 2. These larger ones, actually the cylindrical ones are labeled.
Okay.
They should have a 1 microfarad label on them.
Uh-oh. Y'all, do I have scissors over here? Because this one's not open. Ah.
If it's not open, that probably means it's the bigger ones. So you should have some cylindrical ones that are open. Perfect.
Do these have labels? Let's see. Y'all, I don't have my glasses on. Can y'all tell me if this is correct?
If you bring it up to the camera, it should show.
There we go.
Yeah, so see how it's 5 volts,
Perfect.
Then 1 microfarad, and then 25 volts on the
Got it.
So you're good.
Yay.
So we're going to place that. Connecting pin 2, you'll actually see on this one that one of the legs is longer, just like the LEDs have longer legs. There's a long leg and a short leg. And the long leg, you're going to hook up to, let's see, pin 2 on the 555 timer.
Okay.
And then the short leg is going to go to ground.
Okay.
Pin 2, which is on the top left there.
So the long leg goes to pin 2 here.
Yes.
And then ground is here. How's that?
That looks good, and I see there's a hand raised in the webinar. Jessie, did you have a question? If you could type it in chat, that's probably easiest.
Yay.
Wait, did I raise my hand accidentally?
Sorry, Jessie Bullard.
Oh, sorry.
One of the teachers. Perfect. That's good. And this may actually be a good pausing point. I think we have 1 minute left with the students. Awesome. But we'll pause there on step 1.2.9, and we'll jump into the rest of this on Thursday.
Awesome. Was there a question that came in?
I don't believe so.
Awesome. All right, y'all. And so we will, please let us know, add us on Discord, Britt or Hannah, if y'all can pop that back into the chat. And this will be on YouTube as well, probably within the next 24 hours. It will live on demand here on Twitch, but those are temporary, and so we'll keep it on there for as long as it'll stay up, and then we will have it on YouTube hopefully within the next 24 hours, and we'll make sure that everyone gets a link to it. Oh, Larry! Thank you so much. We're having so much fun. And y'all, thank you so much for joining. This was awesome. I cannot wait until Thursday, and then again, Sue Wern, yay! We are going to be doing this every Tuesday and Thursday for the next 6 weeks, 45 minutes at 10 a.m. Pacific. And we have all of our social media links and everything on that Discord channel, so please follow us. Please ask questions on the Discord channel, and we'll try to answer you even, in between streams. So thank you, Jess and Jordan, for walking me through this. This is so fun. And thank you to all the students in Robeson County in North Carolina. We'll see y'all again on Thursday with the Mentor Project as well.
Thank you, everyone.
Thanks, y'all.
Thank you.